Hello, everyone. Thank you for tuning in, and whether you're starting your day or winding down, thank you for joining us. I'm Nadia, and I'm thrilled to be your host for today's Reactor live stream session. But before we dive into the event, I do just want to bring your attention to our Reactor Code of Conduct. We just want to make sure that this is a positive and inclusive environment for everyone, and that for all participants. So let's keep our interactions respectful and supportive. I do want to show you our Reactor community as well. If you want to stay up to date with all the events that we have going, including in person at the Reactor Sydney, you can join us on our meetup page at Microsoft Reactor Sydney. You can follow us on X, find the content on our Microsoft Reactor YouTube channel, but also sign up to our newsletter as well. But before I hand it over, I do want to talk to everyone about our upcoming Microsoft Build conference. It's our annual developer conference that we have. It will be online this year from the 22nd to the 24th Australia time. If you want to register, you can scan the QR code or head to aka.ms/msbuild2024. So this evening, we are joined by Deepak and Nirmal. So Deepak is a cloud solution architect at Microsoft, and Nirmal is a senior solution specialist at Microsoft. And they'll be taking you through how to master Azure connectivity with ExpressRoute. So throughout this session, you can feel free to drop in your questions, and we'll do our best to get to as many as possible. We'll also be sharing any additional resources for you as well. For those who want to revisit today's session, you can do so on our Reactor YouTube channel. So without further ado, let's give a warm virtual round of applause. And I'm going to kick off with Deepak. Hey, Deepak.
Hi, Nadia. How are you?
Hi. I'm good.
Cool.
All right, let me know when you're ready and I can share your screen.
Yep, I'm ready. Please go ahead and share my screen.
Perfect. So it's showing us at the moment.
Cool. Am I good to go now?
No, your screen sharing is us at the moment.
Okay.
Deepak, your presentation's not sharing.
Oh, okay. I thought.
Sorry.
Let me share. Like, are you not able to see my screen at all?
No, I can only see us on the screen.
Okay.
Let me see if sharing. Apologies.
Yeah, because it was showing me to.
All good.
Sure. Is it working now?
There we go. Perfect. Over to you, Deepak.
Cool. Awesome. Thanks, everyone. Welcome to our session, ExpressRoute Resiliency Patterns and Best Practices. My name is Deepak Maheshwari. I'm a cloud solution architect with Microsoft based out of Perth, Australia. And I'm also joined with my colleague, Nirmal Thivratantri, who's a senior specialist global black belt Azure networking. And both of us are going to talk about different patterns and recommendations for ExpressRoute resiliency. So this is how the agenda looks like. We're going to talk about the patterns for the ExpressRoute, patterns for the gateway and its resiliency. How do we influence the routes and the best practices around the route, and some latest updates and enhancements toward Azure ExpressRoute and hybrid connectivity. Now, why do we need to worry about high availability, right? So this question comes, and a lot of customers, they ask this question, that we are running everything in cloud, it should be highly available. And up to some extent, the answer is yes. A lot of services are made highly available, but outages do happen. And when outages happen, your services are impacted. That's why you also need to worry about high availability and resiliency, baked into your application. Now, why do bad things happen? So things happen because there are hardware under the hood. So data center runs on physical hardware. They can go fail. Softwares can have bugs. So the software is running on hardware. It could be operating system. It could be devices, firmware, things like that. They can have bugs, or they may also need an update as well. And most importantly, people do make mistakes. So it could happen with the misconfigurations from Azure side, or it could happen from the customer side happens. So all of these things could cause the downtime of application availability. Now, why is reliability important? And again, we need to understand that avoiding failure is impossible. So we can't avoid the failures, and the failures will happen. That's why we need to understand reliability and resiliency. So reliability is pretty much like what you want to achieve, and resiliency is how do you achieve it. So to achieve real reliability, you need to build resiliency in your application, in your infrastructure, to make it highly resilient to achieve the SLA or reliability you're looking for. Now, building the reliable system, it's a shared responsibility. So Microsoft has a part to play. So Microsoft has got infrastructure. Microsoft provides multiple Azure regions. It provides the guidance. It provides the high availability on a infrastructure layer, right? That's the responsibility of Microsoft to make sure the cloud is available. It's redundant. It has the capabilities which you can leverage. So the capabilities could be the recommendations we provide. There are tools we provide which you can use and build the resiliency around your application and infrastructure. So it's a shared responsibility, and every customer should also be part of this responsibility to achieve the high availability and resiliency they're looking for. Now, today's topic is around ExpressRoute resiliency. So we're going to talk about the ExpressRoute resiliency and different patterns around it. Now, before I talk about it, I want to go a little bit deep and talk about, different components which makes up the ExpressRoute. And the component includes, you've got the ExpressRoute gateway running in Azure. And that ExpressRoute gateway is basically connected to a peering location. So if you have heard about peering locations, meet me locations, they're pretty much the same. So these are the locations which are outside of Azure region. So take an example of Azure in Australia. We've got a primary region in Sydney, and we have got, or I would say we've got two regions. One is in Sydney, another one is in Melbourne. Now, we also have got different peering locations. So we've got peering locations in Perth, where I am. We've got peering locations, two peering locations in Sydney. We've got peering locations in Melbourne. So these peering locations, they're outside the Azure data center regions. So these are like separate locations. And these separate locations basically have the Microsoft backbone connected with them. And with that backbone, you can essentially connect to any region. So I can effectively use ExpressRoute, connect to Sydney, or I can even use the same ExpressRoute and I can connect to US, Canada, Japan, or any other, region where Microsoft public cloud is available. Now, these peering locations are highly available. So they have got a redundancy built in. So there are like different redundant devices which are used. So if you look at it, we have got the Microsoft Edge router. They're called as MSEE, so enterprise edge routers. So these are like multiple redundant routers. And then from your service provider side, they have got redundant devices. So when you are on ExpressRoute, what you get is you get two connections. One is primary and secondary. So you get two cables, which you can actually configure to two different devices for the high availability from your side. So these are the components which makes up the ExpressRoute. Now let's talk about different resiliency model. So we talked about Azure regions, like we have in Sydney, we have Azure region in Melbourne. Then we talk about the peering location, that's separate, building facilities altogether. Now, how do we achieve the resiliency? So there are like different models. Like the first one is standard resiliency model. Now, in the standard resiliency model, we have got a single ExpressRoute, and we've got this single ExpressRoute connected to a single site. So we've got one ExpressRoute, which has got primary and secondary connection. And these two connections are connecting to one location. Now, this is kind of a least resilient, and I'll explain why I mean by least resilient. because a lot of customers have got this configuration already done. It doesn't mean like it's gonna have the downtime, but it's least resilient. And we'll explain when we go to the next part of the section that what can go wrong in the ExpressRoute configuration. Now, what can happen is within the one peering location, as I talked about, we've got a primary and secondary connection. So why do we provide primary and secondary connection? One of the reason is that you've got independent, infrastructure, the routers and connection. And if there is any maintenance going on, it will not impact to the secondary connection, which means only the primary connection will be going through the maintenance window and the secondary connection will continue to work. And that's why we recommend customers to configure ExpressRoute in an active mode instead of active passive mode. Because if you configure a single ExpressRoute circuit in active passive mode, and if there is any maintenance going on, you will encounter the downtime. So that's where it's recommended to have active, and the maintenance goes on and it won't impact your ExpressRoute connectivity. So that's why you need to understand why you need to have active connection. Now, ExpressRoute circuit highly available design. So we are still talking about a single ExpressRoute circuit, single on premises and single Azure region. So there are some recommendations. So I just talked about active mode, means both your primary and secondary connections, they should be active. That's the recommendation. If you don't do that, you're not going to achieve the SLA or commitment, of high availability from a Microsoft side. So we don't want a single point of failure, because that's why active is important. Now, on top of it, Microsoft recommends to use BFD. So that's the bidirectional forwarding detection. So this is kind of a lightweight UDP protocol, which you can enable on your on-premises router. And what it does is it basically quickly detects if your primary or secondary circuit is down. Since they are active, if one of the connection is down, you can still route all of your traffic using secondary or primary, whichever is available connection as well. So that's why it's recommended use BFD, use your connection in active mode. That's the high recommendation. Now, talking a little bit more about the BFD. So as I said, BFD is a UDP-based protocol. So this is basically used for failure detection in the routing protocols, so BGP, ICMP, and some other protocols. They also use BFD. Now, if you do not use BFD, what's going to happen is that the BGP, timeout will kick in, and the failover will happen to the secondary, connection. But that could take its own time. So it could take up to 3 minutes, because BGP is like a heavyweight protocol. So it takes time to refresh all the configurations, and it's going to take its time. So that's why if you enable BFD, that could happen in few seconds. From a Microsoft perspective, BFD is already configured in the Microsoft Enterprise Edge router. So Microsoft has configured it from its side of the router. As a customer, you should configure the BFD to achieve the active, kind of the resiliency model in your ExpressRoute. Now, there are different peering locations, as I talked about. And again, I'm talking about the main Azure regions we use in Sydney and Melbourne. We've got, 4 peering locations. We've got Perth peering locations. We've got Melbourne. We've got Sydney. And recently, we also introduced another peering location in Sydney, which is Sydney 2. And we will talk more about it, because why more peering locations are there, because of the high availability. And you also see that what are the service providers which allows you to connect to ExpressRoute from these peering locations. So every peering location could have very similar or different service provider in order to connect to your last mile connectivity. Now, what happens if your peering location is down? So I just talked about, we've got 4 peering location. these are independent facilities. These facilities are not running in Azure region. So they're not sitting in Azure Sydney or Azure Melbourne. They are a separate facilities. They are a separate building. They have got a separate power connections, connectivity, or everything. But they can go down. And it has happened in the past that some of the peering locations had an outage, and that actually impacted to customers' hybrid connectivity. So now let's talk about different model which Microsoft has introduced, and you will find all these information to our website. So second model is the high resiliency, and this is something which we have recently announced, and my colleague Nirmal is going to talk more about this in a few minutes. So this is pretty much, we have got two connections, and these two redundant connections are actually using two different facilities, and those facilities are like close to 5 kilometers apart. So they can tolerate if one building happens to be down, you still have got your traffic routed using different building. So similar to one ExpressRoute circuit using one peering location, in this case, one ExpressRoute circuit will use two different peering locations. Now, be mindful of the fact this is recently announced. This is in preview. This is not available in Australia currently because this is only available in specific of the few regions where it is introduced. It will come down to Australia gradually. Now, the third one is the maximum resiliency model. So this is something we recommend if you've got like a mission critical application which has got a lot of dependency on premises, or any application which will be impacted if your ExpressRoute goes down. We recommend to use two peering location. So you could use one peering location. Let's say if you are in Perth, you can use one peering location as Perth, second peering location in Sydney, or if you have data centers in Sydney, you can even use peering location Sydney and Sydney 2 as well. So you can effectively use two peering locations. And what it requires is that you need to set up two ExpressRoute. So you will have ExpressRoute Circuit 1, which is using one peering location. You will have ExpressRoute Circuit 2, which is going to use the second peering location. And what it will provide you is the high availability in case if one of the peering location goes down. So it's kind of effectively giving you two parallel paths. And obviously, we'll talk about some of the routing configurations or consideration to avoid any asymmetric routing. But that's something we recommend as maximum resiliency if a customer is required to have a maximum resiliency for their application. Now, there is another option within the maximum resiliency. You also have got a bow tie design, and this design has been around for a very long time. A lot of customers in Australia, they use both, primary, region. They use it as Sydney, and they use secondary region as like, Melbourne. So you might have, Azure regions used for your applications as Sydney and Melbourne, and you can have two ExpressRoute circuit, and those two ExpressRoute circuit can have a peering locations, maybe first in Perth, second in Melbourne, or second in Sydney, or maybe first in Sydney and Melbourne, depending upon from where you are connecting to Azure. Because I'm based out of Perth, so that's why my example is always starting from Perth. But in your case, your peering location, first peering location could be Sydney and second could be Melbourne, or vice versa. Doesn't matter. So you can have two peering locations, and both peering locations, you are connecting your ExpressRoute circuit to both Australia East, which is Sydney, and Australia Southeast as Melbourne. For the second ExpressRoute circuit, you're connected to Australia Southeast, Melbourne, and Australia East as Sydney. So it's pretty much like a bow tie kind of a configuration. Now, the benefit of this approach is if one of your ExpressRoute happens to be down, so take an example, if you've got a traffic, and if your traffic is basically originating, let's say, from here, and it's going here, and let's say this circuit is down, what will happen? Your traffic will basically be routed via this path. So you've got this redundancy built in to kind of withstand if your ExpressRoute peering location happens to be down. So that's That's the recommendations, we have as bow tie design, versus if you've got the first scenario, you've got like one location and one Azure region, you still use the two ExpressRoute circuit to have the maximum resiliency. So that's why I put it in, A and B as a pattern to be used. Now, we talked about the peering location and resiliency for the peering location. What about the ExpressRoute gateway? So when you deploy ExpressRoute, what it does is it deploys, couple of appliances in Azure. Now, there are different gateways available, and if you have not chosen the right SKU, it can also cause the downtime. So what is recommended is you use the zone redundant SKUs. So you've got a regular SKUs which have been around for a long time, like basic, standard, high performance, ultra performance. But these gateways are not zone aware. Microsoft recommends to use zone aware gateway. Microsoft recommends to use, availability zones for the higher, resiliency and redundancy. That's where the same rule applies for the gateway. So use the zone redundant gateway. And in that case, it can withstand any of the zone failure as well. So that's the benefit you get in the zone redundant gateway. And in this case, you could see, the gateway is actually deployed across multiple availability zones to provide you the high availability. So that's something to remember, like if you are even using multiple ExpressRoute circuit, but you're only using the regional gateway, then you can still have the downtime because of the gateway is not highly available. Now we talked about the patterns. Now let's talk about how do we influence routes and some of the best practices for the route. Because if you've got one express route, then it's not a problem. You can have two connections. You can pretty much keep them active. They are going from the same facility, sometimes from same router. So it's not a bit of an issue. But what happens if you've got multiple express route? So a lot of enterprises, they have got multiple express route. And that's where you really need to plan it carefully. So your network design should be configured in such a way that it can avoid the asymmetric routing. And there are some solutions around it, right? You can use like more specific route to advertise which express route circuit you want to use versus the other. You can also define the higher connection weight for the traffic coming from Azure. You can also use the BGP attribute that's called as AS path prepending. And what AS path prepending does is it just prefers one path over the other. And if the first path, which is the preferred one, is down, it will use the another path. So you can pretty much use the high availability, configurations for the protocol. Now let's just talk a little bit more about it, right? And I have put this in two different contexts. Like if you've got kind of a small to medium size enterprise, where the customer has got one single Azure region, one single on-premises location, but two express route circuit. Because we are talking about the maximum resiliency. Now that's why we are talking about two express route circuit. Now in this scenario, what happens is we have got two circuits, and the way this configuration is done. So the blue line and blue dotted line. So the dark blue line is representing the preferred connection, and the blue dotted line in the right, it's showing as a backup connection. Now, what we're doing in this case is we are actually advertising the routes, and the routes are advertising with /25 prefixes. So the subnet you would see is /25, which means we are advertising the route from on-premises, which are more specific route. So /25 is going to be more specific. And in the case of Azure, it prefers the longest, prefix. So if you've got the longest prefix, which is /25, this is going to be the preferred, route. And there's another route which is advertised /24. So obviously /25 is the more specific route. So it's going to be preferred over the 24. However, if /25 or that express route happens to be down, your traffic will be using the secondary express route circuit. which is /24. So this will provide that resiliency that if one ExpressRoute circuit happens to be down, and let's say you're using the gateway which is zonal or zone aware, in that case your traffic will be routed via the secondary ExpressRoute. Now, a lot of these configurations are done on premises, so be mindful of the fact that these routes which you advertise, they are done at on premises, and you also use local preferences to influence which router you want to use in order to communicate to Azure. So you also configure the local preferences, which is a BGP attribute, to influence your route at on premises router. Now, the second option is AS path prepend. So we talk about the more specific route, which is good, but sometimes that's challenging. If you've got multiple routes, then you have to have a calculator and keep looking at what route you're going to use. And it might be a bit difficult to troubleshoot as well. So that's where we've got AS path prepend. This is another BGP attribute which you can use. Now, in this case, what happens is you actually have got the same routes, and those same routes are advertised, but they're going to use the ASN, which is 345 in this case, in this example, and you're going to prepend this in your ExpressRoute 2. So maybe you want to use ExpressRoute 1 as a preferred one. Maybe I'm connecting from Perth. For me, the Perth peering location is preferred. I may have second peering location in Melbourne, and connecting to Sydney region of Azure, and I feel that's going to add more latency, but I want to use it as a backup. So what I'll do is, for my preferred ExpressRoute circuit, which is going from Perth, I will use the AS path, that's 345, and for my next connection, I will prepend it. So I will make it double 345 345, and what will happen in that case, my first ExpressRoute circuit will be preferred for all the communication. My second circuit will be kind of a backup or a standby circuit. And if the first one is unavailable, the second one will kick in. So that's something I can use, and especially that's something which I've seen most of the customers they use, because it's easy to configure AS path than configure the specific route. And in this case also, I need to use the local preferences to influence which path I want to use. So I need to configure this on my ExpressRoute, on the routers which are connected to my ExpressRoute, which is the local preferred router for my scenario. Now, when it comes to communication from Azure to on-premises, so there is a configuration in Azure ExpressRoute circuit. You can also configure the routing weight. So in this scenario, if you've got primary, secondary, or multiple ExpressRoute, connected to the same gateway, you can also configure the routing weight. So weight is also, again, a BGP attribute. So that's available in Azure portal. You can define the weight. So higher the weight means higher the value. So if I put weight as 100, that means from Azure, I'm always preferring this ExpressRoute over the other. So I can define my weight as 100 for one of the ExpressRoute, and for the second ExpressRoute, I can configure the weight as maybe 50 or 10 or 99. My 100 one will always be preferred. So that's something you can do in order to route the traffic from Azure to on-premises and avoid any asymmetric routing. Now, let's talk about large and distributed enterprise network. Now, we kind of take it to the next level and talk about what happens if you have got multiple on-premises location. Two is just for an example, but you could have multiple on-premises and multiple Azure regions as well. Now, in that case, you have the solution one, which is like using the connection weight and local preferences. Now, in this case, I can have my traffic, which is basically advertised on both of my on-premises router. I will use the local preferences for my on-premises router, and I will also use the weight, which is the properties configurations I do it in Azure portal. to route my traffic. Now, what will happen in this case? Maybe my on-premises, which is 10.1.11.0, that traffic will always be using the preferred express route because I have configured in my local preferences, right? And the secondary connection will have 10.2.11.0/24. That's configured as the local preferences there as well. And on the weight from the Azure side, I can configure the weight as 100 for my primary connections, and for my secondary connections, I can have the lower weight. Means when the traffic is routed from Azure, that's basically what will happen. That's going to use this weight, and maybe the connection I have here, I could have a weight as maybe 10 or 20 or lesser in this case. So with this kind of configuration, what I can do is I can essentially avoid any asymmetric routing, because what I don't want is my traffic, let's say this is Sydney and let's say this is Melbourne. Because if I've got a multiple path, multiple connections, what I don't want is my traffic is going like this, or my traffic is going like this. I want to avoid any sort of misconfiguration. So that's where it's important that I set my configurations correct, and I also want to avoid asymmetric routing. Now, the second solution is AS path prepend. So you could see it kind of shows the option 1 and then option 2. So option 2 is the AS path prepend. The same way I can advertise the same route, but I can add the prepend, right? So I have got 10.1.11.0. That's my route from this router, and I've got 10.2.11.0. That's my secondary location. Now, what I'm doing here is I am actually, advertising both the route. The only difference I'm doing is that I'm actually adding the AS path prepend. And what this AS path prepend is going to do, it's going to make the secondary path as the kind of a secondary choice, right? So the first one, which has got the ASNS 345, that's going to be the preferred one. And the second one is always going to be as a backup. If the first one happens to be down, then the secondary one will kick in. And what it will essentially give me, it'll give me kind of a mesh kind of a connectivity. So if any of the express route goes down, I still have a path to connect to my Azure region, because now I'm actually effectively connecting using my secondary express route, peering location as well. So that will give me the high availability and resiliency to avoid any downtime from express route, peering location perspective, or if there is any issue with the connections, I would be able to use the secondary location. Now, how do you see the AS path prepend? You basically see the routing table. So in Azure, you've got the express route, and express route have its own routing table. So you will see the AS path prepend. So in this case, it's prepend 2 times. I think you can go up to 12. That's the limit. But if you have a prepend, that means that path is least preferable. If it doesn't have a prepend, means that path is preferable. So that's how you kind of make your configuration. So that's pretty much I wanted to cover. Now I will hand over to my colleague Nirmal to talk about latest updates and enhancements around Azure ExpressRoute.
Perfect. Thank you, Deepak, and thanks for walking through all of the different design approaches and design patterns for ExpressRoute. So the next 20 minutes or so, what I'm going to cover, I'm going to look at how do we improve the experience for a customer or a user when they create the ExpressRoute circuits within the Azure portal. I will also touch on what Deepak mentioned about the new Metro offering, and then we'll also have a look at some of the new capabilities we've introduced relating to the ExpressRoute gateways. So that is what I'm going to cover. I'll run through few demo scenarios, show how some of that works in the Azure portal. Also, if there are any questions or things that you would like to discuss, yeah, feel free to make a comment in the chat as well. So the first thing I do want to cover off is the improvements we've done in the Azure portal to provide customers with different patterns around resiliency. So what I'm going to do is I'm going to switch to the Azure portal, and then I'm going to give you a comparison between what does it look like in the current experience and also what we are doing in terms of the guided experience that will give you more details and also give you information when you plan your ExpressRoute connectivity. We'll provide suggestions around how can you make the resiliency better. Also, we'll give you information around the distance, the pattern based on the pattern you've implemented, whether you should do active-active connectivity or whether you should do active-passive connectivity. So with that, I'm going to switch to my Azure portal. Let me zoom it up. All right. So what I'm going to look at is this is the current available release of the service. So I'm going to go to ExpressRoute circuits. And in the ExpressRoute circuits, I'm going to say I want to create a new circuit. So this is the UI experience that you are familiar with. So what we would do is we would create a new resource group, or we would select an existing resource group. We would select a region. So let's say this is for Australia. You would provide a name. So let's say this is for ExpressRoute Circuit 4. And then you run through your standard configuration steps to provide who's the provider or whether you would be configuring ExpressRoute direct. So this is the current experience for users. What I will do now is I'll switch to a different tab and I'll walk you through what are the improvements we are doing with the guided experience. So let me switch to this tab and then I'm going to run through the exact same process, but you will see that there are new changes that we've added in the user interface. So now here, when I go and create a circuit, you can see we have some selection that customers can do. So example, we now provide a resilience tab. So we allow you to select, whether you want to go for a maximum resilience pattern or whether you want to go for a standard resilience pattern. So again, very similar to before, I can select the resource group and then I can select the pattern that I want to configure. So depending on the pattern, you will see that the UI will change. So depending on what you select, we will provide an updated UI with more details specific to your environment. So what I mean by specific to your environment is if I select, I want to do maximum resiliency, and you can see here we don't have any customer specific information yet. But what I'm going to do next is I'm going to select either I can select an existing circuit, or in this instance, I want to create a new circuit. So it's going to say ExpressRoute Circuit 4. I'm going to select a provider and a peering location. So let's say the peering location that I need is Sydney. And then I will select a provider. So I can use any provider that's available from that particular peering location. I'll select Megaport for this demonstration. So I've selected some settings for the first ExpressRoute circuit. And you can see that when I select that, it's now updating this UI to say, you've selected the first circuit, and then I can choose a second circuit. So here what I will do is I'll select the same region. I'm going to say this is ExpressRoute Circuit 5. I get to choose a provider. I can use the same provider or I can use another different provider. But what's important here is that I can now select an edge location based on the distance. So this is important for customers who are deploying. This would give you information to understand if there are any closer edge locations. So here, as an example, you can see, 16 kilometers apart, there's a second edge site that I can select, or I can select the ExpressRoute circuit to be deployed to Canberra, Canberra 2, Melbourne, Auckland, or Perth. So I can select the location based on the distance and make a choice on how that configuration should look like. So in this instance, I will select Sydney 2. Then I can select the provider. Again, the provider will get scoped based on the edge location that you select. So once you do that, you can see the diagram here is also updated. So we have visual representation on how the configuration looks like. So we have Sydney, Sydney 2. We also measure the distance, and we are providing you a visual representation of what the design that you're about to implement looks like. The other thing we also provide within this UI is also guidance to say, depending on the location, we're also saying whether you should do active on the circuit. So you can see here, circuit 1 from peering location Sydney is 16 kilometers away from circuit 2. And we are saying based on distance, you can have this as a highly available redundant circuit, and you can load balance across the two circuits. But that's not going to be the case if I go back to my peering locations, and let's say I'm selecting Perth, which is 3,287 kilometers apart. So that's not ideal for me to do active because some traffic will go via the Sydney circuit, and then some traffic will start going via the Perth circuit with a lot of latency added to it. So if I select, again, I'm selecting the same provider, but you can see in here we are now saying you should use this as a redundant circuit, but you're not going to use this as an active circuit. Instead, we are saying use this as an active standby circuit. So there was a question before around how do we make the circuits active standby, and Deepak covered this during the patterns that he looked at. So we can use BGP methods such as ACE path prepend, or advertising more specific routes to say, you prefer this circuit over the other when we are selecting that circuit for traffic from Azure to come back to on-premises, or we can apply the connection weight configuration to say which path should be preferred. So that is all up to the customer to go configure. But in this particular UI, we would provide a guided experience for customers. When you are creating your circuit, you get to select the resiliency model first, and then based on that, we would allow you to configure the circuits, and we'll also provide you suggestions around what is that second edge should look like, what's the distance, and then based on that, we would provide suggestions as to do you run active or do you run it as an active passive scenario with the two circuits. So that's the guided experience. The other capability that I want to cover is, so we've looked at maximum resiliency and we've looked at standard resiliency. We also have a new offering in preview today, which is in between. We call it the high resiliency approach. So in the high resiliency approach, what we are providing is two connections very similar to standard express routes, but one connection will go through one edge and the second connection will go through the second edge. So this will allow you to select the metro enabled edges, and then we will ensure that the connections, whether it's a ExpressRoute direct port that you've ordered, or whether you are provisioning an order for an ExpressRoute partner circuit, we will ensure that the handoff from Microsoft to the customer would go through two different edge locations. So I will also demonstrate this as well to show what does it look like in the portal. Also, what does it look like once it's provisioned? How do we know that this is across two different edge locations? So let me switch to my Azure portal. And then what I will do, I'll first show the documentation for this. So this is the Metro documentation. So you can see that the service is still preview. Also, the other key thing to note here is the location. So there's only few locations that are enabled today. And this is then planned to be gradually rolled out. So you will see other locations getting added. And at the same time, you'll see there'll be other partners that will get added who will be able to offer this Metro service to customers. So what I will do is I'll go ahead and create a circuit. So let me use the create link in here. And then what I will do is I'll show what the difference is when you go and select a Metro enabled circuit. So we can also configure the Metro enabled partner circuits, or we can also go ahead and create an ExpressRoute direct where we are getting the ports, and then we are able to part of the Metro provisioning will then automatically select the two edge locations where the customer will connect. So again, very similar to what we were doing before. We go create a new circuit, and then what we do in here is I will select the same resource group, but in here, when we are selecting the provider, so let's say a new circuit, let's say this is circuit 5, and here I'm going to select the peering location. So when I select the peering location, if I search for Metro or Amsterdam, you will notice that I will have an option to go and create the Amsterdam circuit in the Amsterdam Metro location, which will then make sure that the circuit gets created with the two edges when the configuration is done. Let me try to create it as a direct resource. So let me try new. And what I will do, I'll just go back and I will go to ExpressRoute Direct. So with Direct, what we do is we are essentially ordering a new ExpressRoute port. So in here, we are not leveraging a ExpressRoute partner, but instead what we are doing is we are creating a new ExpressRoute Direct resource. So let's say this is ExpressRoute Direct 5. Click Next. And then here we can select the peering locations, and peering location will then show you what are the available locations that are enabled. So here we can see this is a direct location. So I can select Amsterdam Metro location. Also, we should have Singapore as well. So yeah, so you can see we have Singapore available. So we have few locations that we've enabled. And then once the configuration is done, you will be able to generate the letter of authorization from the ExpressRoute Direct resource, which will give you the location of where the configuration is created. So I'll just go back to the homepage, and then what I will do is I'll go to my existing ExpressRoute Direct resource. So you can see this is a ExpressRoute Direct already created in a Metro location. And then what I can do is I can click on this generate letter of authorization. So this generates the letter of authorization where you provide it to your data center provider, and they will then create the cross-connect configuration as needed. So this is what the letter of authorization looks like. So I'm just going to zoom in. The key thing to look at in here is the colo facility location. So you can see here the first facility is Equinix in Amsterdam AM5. And then if I go to the second page, you will notice that this is a different colo. So this is essentially doing one 10 gig connection from one colo, and we are doing the second connection through the second colo. So we are not terminating both 10 gig ports in the same edge. Instead, we are having one terminating in one co-location facility, and then we are allocating the second port on the second co-location facility. So that is what is happening with the metro configuration. So essentially gives you the ability to, rather than having to have both terminate in the same edge location, you can now select to have one port terminating to one edge site and then have the second terminate on the second edge site. We can also view that information in here as well. So you can see here in the colo field, you see these two options that are available. So that is new in preview, the metro configuration. Outside of it, while we are in this ExpressRoute direct view, I do also want to highlight, we've also recently rolled out the ability to configure rate limiting on the ExpressRoute circuits that are created with ExpressRoute Direct. Because in the past, if you have a 10 gig ExpressRoute port, and if you create a 1 gig circuit, there's no rate limiting applied, which means that 1 gig circuit can essentially take over all of the bandwidth available in the ExpressRoute Direct port. So to mitigate that, rate limiting is now available for circuits that are created with ExpressRoute Direct. So if you go to the configuration tab, you will see that there is a new option in here that says enable rate limiting. So you can now turn on rate limiting, and it'll then apply rate limiting based on the bandwidth and the sizing you picked for that particular circuit. So that will not allow the port to get saturated if you created a 1 gig circuit and then it's trying to take over all of the bandwidth that's available on the ExpressRoute port. So that's a quick update on the ExpressRoute Metro. Let me move on to the other two updates that I want to cover. So the other two updates relates to the gateways. So one of the key challenges that customers have is the approach for upgrading the gateways. So there are customers who've deployed with the standard high and the ultra gateways in regions where we have availability zones. And as you know, the standard high and the ultra gateways are non-AC gateways, which means that we don't guarantee that the VM's underlying compute used by the gateway is deployed across availability zones. And the way to upgrade it to an availability zone gateway is you have to delete the gateway and recreate the gateway. Now, the challenge in doing it, it's a longer outage window because it takes 20-30 minutes for you to delete the gateway, and then you have to recreate the gateway, which will take another 20-30 minutes as well. So you are looking at an hour or so just to perform the activity. And if you want to factor in any rollback time, you're looking at a 2-3 hour outage window. So in order to make that experience better, the engineering team released this seamless gateway upgrade capability. This is available for customers to use in preview today, and it's available in any Azure region. So if you are specifically in a region that has availability zone support and you're running on a gateway that is not using the availability zone enabled SKUs, this is a good option to go ahead and upgrade the gateways. And it has very less downtime because what we do is we build the gateway side by side, and then we will switch over the data plane and the control plane operations. So there's a less disruption. You should still do it within an outage window, but less disruption comparatively to having to delete the gateway and then recreate. So let's have a quick look at the gateway migration option as well. Again, there's documentation in how to do it. There's a PowerShell script to do it if you want to do it through more of a pragmatic, programmable approach, or you can use the portal option to do it through the UI as well. So this is the UI option. So I've gone into the portal that has this capability enabled. So if I select the gateways, you can see this gateway is using the standard SKU, and I've deployed this to Australia East, which supports availability zones. So if I go to gateway SKU migration, you can see that this new UI is available, and I can run validation, right? So validation will check what's the state of the gateway. It will make sure that I've completed some of the prerequisites. So one prerequisite is to allocate a new address range to the gateway subnet. So you could do these prerequisites. So once you're done, it will then make sure that the gateway is ready, and then you provide the new information about the name of the gateway, what SKU you want to go for, and also you can choose the IP addresses, the public IP that's going to be associated with the gateway. And then you can run through, it'll do a preparation, and then it'll migrate. It'll provision the gateway and then allow you to migrate. The other update I did want to cover off is with the current ExpressRoute gateways, if you are deploying the gateway to a hub spoke environment, the gateways can only scale up to 10 Gbps. In the case of virtual WAN, the ExpressRoute gateway can go up to 20 Gbps. But we have use cases where customers need higher bandwidth. And the approach today is you enable what we call as a fast path that allows you to bypass the gateway. But fast path approach has its own limitations. So due to this, we have also announced the scalable gateway that customers can leverage. So the benefit of a scalable gateway is you can now set the starting and the scale units that you want. So you can start from 1 Gbps and say, I need this gateway to be able to handle 40 Gbps of traffic, or you can allow the gateway to auto scale as well. So let me switch back to my Azure portal, and I'll quickly show how this looks like as well. So let me look for my gateway. Yeah, so this is the one. So this particular gateway, when we create the gateway, you can now select this new gateway SKU, which is the ERGW scale, which is for the scalable gateway. And part of the scalable gateways, you have these configuration options where you can now set a minimum and a maximum scale unit. So this can go up to 40 scale units, and that will then allow the gateway to operate at that particular capacity, or you can let it automatically scale up based on the throughput demand and based on the requirements in terms of what kind of workload you run. It will automatically scale and provide scalability up to 40 Gbps from a throughput point of view. So those are some quick updates, building on to what Deepak covered from a resiliency point of view. This is to cover what are we doing in terms of the portal guided experience. So we looked at what's available in the portal. We've looked at ExpressRoute Metro, which is in preview, and there are new edge locations being onboarded, new partners being onboarded for Metro. And we've looked at how does Metro look like for ExpressRoute Direct, where we have one handoff 10 gig port in one edge location, the second on a second edge. And then we've also looked at what are we doing from a gateway point of view to help customers upgrade to the more resilient availability zone aware gateways. And I've also covered the scalable gateway. If you want to get higher throughput, higher bandwidth up to 40 Gbps, you can look at the scalable ExpressRoute gateway. So all of the other things that we talked in this session, we've also added all the reference links. So there are a number of reference links here. We'll also share this for those who've registered and provide the reference links for building resilient connectivity, hybrid connectivity to Azure, also leveraging multiple locations, and also I've added all of the links around the Metro creation, scalable gateway, and also the portal migration experience. So that's all what we want to cover. Let's have a look and see if there are any questions. But essentially what we want to provide is an update on the resilient patterns, how to think about connectivity resilience, and then also wrap it up with some of the feature updates and enhancements we've done in the platform. Thank you all for joining, and we'll have a look at the chat to see if there are any questions. I can see, Deepak, you've answered most of the questions, so that's good. Any other questions, Deepak or Nadia? Have you seen any?
No, it seems like both of you have gone in and answered them for each other, which is great. A lot of good
Super.
questions coming through as well. Hey, Deepak.
Perfect.
Awesome. Well, thank you both so much for providing the update. That was great. And I will make sure that I share the links with everyone who's registered and also attended today.
Yeah.
I did want to, Deepak, Peter wants to know if he can reach out to you.
Oh yeah, sure. Yeah, I think available on LinkedIn. So yeah, you can definitely reach out to me. Yeah.
Perfect. And I've also just popped in a link to a survey as well. We always strive to give the best content and would love to hear any feedback from today's session I can pass along to Nirmal and Deepak. Thank you both again. And thank you everyone for joining, and we'll hear from you all next time. Bye for now.
Yep.
Cool.
Thank you.
Thanks.
Take care.
Nadia. Thank you. Thanks everyone for joining in. See ya.